All right, so for our final project, we are at the point where we've picked something that we're saving for. We have a number in mind for what we're saving, and now we want to actually use some different saving options or investment options to achieve that goal. So there's four standard ones that we can pick between. If you want to go outside this list, you are welcome to, but you're going to have to conduct your own research and justify it in your project if you want to use a different type of account. But here's four standard ones that we'll typically see. This first one is a savings account, typical savings account from a bank, and you'll notice that it has a really low interest rate, 0.06%. So when it goes into our formula, it's going to go in as 0.0006. The reason this interest rate is so low is there's no risk involved because it's government insured. So you're guaranteed to get that money. But you'll see as we explore in Desmos, it may take a lot of time to achieve your goal. All right. Then we kind of build up as our interest rates get higher. Notice how the interest rates get higher as we go. That's a good thing between high yield savings, bonds, and stocks or mutual funds. The risk also gets higher as well. We go from government insured on our low end savings accounts. We get some potential fluctuation in our high yield savings accounts where maybe those interest rates aren't guaranteed over time. Our bonds, same thing where maybe they aren't performing at the 6% consistently. So our model may not work. It may take us longer than we're planning for. In stocks or mutual funds, especially, subject to complete losses. These are high risks. A student yesterday basically said, hey, this is legal gambling in a way. You're betting money that a company will do well. It's pretty widely accepted in America's economy to purchase stocks and sit and wait, but very, very risky as well, which is why it comes with that like 10% return rate. So I'm going to do some modeling with my project, run through basically scenario one. We're going to use Desmos for that. So go to Google Classroom to access this Desmos template. And once you're there, we can start using this formula to set up our graph. So we go to Google, or we go to Desmos, which we grabbed from Google Classroom, and we are going to start building up our formula. So first thing I want to do is I want to write in my goal. We're going to write that in with A parentheses T parentheses equals, and my number is 42440. And you'll notice that I typed in a comma here and it caused an error and nothing showed up on my graph. We want to delete that comma. We want a straight line there. So this green line is going to represent, that's my goal. Notice how over time, 0, 5, 10, all the way up to 50 years, this line never changes. It's always going to be my goal. All right. Then we're going to use this exponential growth formula that we saw earlier. P times 1 plus R to the T power. We're going to throw that in there, except I'm going to throw some initial values in. A T equals, and let's say I want to set $500 aside to start. So 500 will be my P times 1 plus R is the next thing we have to decide on. So if we go back, let's maybe start looking at this savings account first, where we use that 0.0006 as a start. So 1 plus 0.0006, and that's raised to the T power. And if we look at that, we get this purple line, okay? And that's the amount that I've saved over time. And we notice that it stays really, really flat. And even if I change this number, this initial amount that I'm investing from 500 to maybe 5,000, yeah, it goes up to 5,000, but it stays really, really flat over time. So let's try something more ridiculous like 15,000. Okay, we're starting to see some growth here from the interest as we go on, but it's taking 50 years. Let's try 20,000. Oof, still not great. Maybe jump all the way up to 40,000. Okay, we're starting to get there. But you can see that, hey, I don't actually cross my line until 98 years in the future. So that's not realistic for me to have a swimming pool. And also, I don't have $40,000 to set aside right now, right? If I did, I'd be pretty close to just buying my swimming pool goal. So that interest rate won't really cut it for us, or at least for me. So I'm going to start kind of moving up this chain here, going into some higher risk stuff. So let's try out this high yield savings, 4%. So I'm going to change my rate here to 0.04. I'm going to change my initial investment down to, maybe let's go back to 500 again. Look at this. And again, we're starting to see some growth, but it's way out in the future, 110 years. So that's not really realistic in this scenario. Let's check it out if I change that P value to 1,000. Okay, still not very good. Maybe 2,000. Definitely want to hit this within 50 years of my life. So I'm going to keep kind of bumping up this 1,000 at a time, see what I get. Okay, 4,000 is getting there. 5,000, 6,000, 7,000, 8,000. Okay. It's not great, right? We have, if I trace my graph, I see where it intersects. I'm going to hit my goal in 40 plus years. It looks like 42 and a half years exactly. That is not ideal. Um, and 8,000 is still a lot of money to have just lying around. So I'm going to bump this up one more. I'm going to accept a little bit more risk, moving up to bonds, which have a medium risk and subject to lower performance here, and get a 6% return. So I'll go in, I'll adjust my interest rate to 6%. Okay, $8,000 set aside, and it's going to take me, it looks like 29 years, that 28.637 number to reach my goal. So I'm I'm okay with this. We'll see tomorrow that there's probably a better option of setting aside a little bit at a time to reach my goal quicker. Um, but in 25 years from now, 30 years from now, if I have a pool, that'll be just in time for my retirement, I guess, and we can work with that. So what we'll do then is we're going to start um, filling out the rest of scenario one. Okay, if you look at your requirement stock, we'll start filling that stuff out. So I have my swimming pool, which is 42,440 is the cost I'm going to have. The formula that I'm looking for is this formula right here. So you have this formula I'm circling. A of t equals 8,000 times 1 plus 0.06 to the power of t. And you can just copy that from Desmos if you want. If you want, you can write it in or type it in your math equations. But we used A of t equals 8,000 times 1.1 plus 0.05 to the power of t. Okay, I'll clear that out just so we can see our screen a little better. The graph. You're going to take the graph from Desmos. So I'll just kind of jot in from Desmos. All right. We will go in. We'll probably want to clean up our graph first, maybe change these line colors. Let's use red, and let's use a dashed line for my goal. And let's use green as my savings line. And then if we go, we can take a screenshot of this. I can show you how to do that in class. And we can paste this graph into our project page. Then if we look at the rest of these items, the type of investment we chose, all right, let's look back. We chose the bonds, which had a 6% return. So we chose bonds for this scenario. And we chose to invest $8,000 initially. All right, that's our principal investment, $8,000. Okay, and those are all zeros there. Sorry, 0, 0, 0. Next, the time required to reach the goal. If we look at our graph and our intersections, hover over that intersection point there. That first number is our x coordinate. That's going to be our years. Looks like 28.6 years is a good number that we can round to. So the time required to reach the goal, 28.6 years. And that interest earned, that is going to be just a simple subtraction problem. Our goal was 42,440. The amount of money I put in was that principal investment, that 8,000. And that means that our interest earned is equal to, I believe that would be 34,440. So the final thing we'll want to add to our project for this section is just a kind of commentary about, hey, what are the pros of this scenario? What are the cons of this scenario? How realistic is it for us to do? Notice how, oops, I lost some of my notes here. Hold on, let me see if I can fix that. Send it back. Oh, that made it worse. Well, some of the pros are, hey, it's a pretty low risk investment or medium risk investment, and I get my swimming pool within 30 years or so. Some of the cons is that, hey, I got to set aside $8,000 up front. That's a lot of money to have just lying around. So it may not be super realistic there. Also, would I want my pool a little earlier in my lifetime? Do I really want to wait till retirement? Those are kind of the questions we want to answer with our pros, cons, and realisticness. So, in terms of your checklist for scenario one, this checklist is kind of on the back of your project requirements as well. But I got it broken down step by step here. To be on track for scenario one today, we need to have our exponential growth formula figured out using those Desmos steps. We need our graph displaying our goal and formula, and then we need our summary, just kind of addressing all those different questions.